Okay, so we are doing this committee and combination problem. They are generally asked in competitive exams. So the question here is John is teaching at Wills High School. Okay, and there are 12 teachers, including John, and they want to form a teachers uh, committee. So they want to form a three-person math committee and a four-person physics committee. So John uh, is already preoccupied. So he wants to be either in math committee or in physics committee or maybe in neither committee, but he doesn't want to be in both the committees. So how many ways committee can be chosen? So, first we'll find what are the total number of ways math committee can be chosen. Okay. So, total number of ways math committee can be chosen will be 12 choose 3. Okay. And we know the formula. It is suppose this is nk. So it will be factorial n. Okay. Over factorial m minus k factorial k. Okay. So if we find this, okay, and then total number of ways, okay, total number of ways physics committee can be chosen is 12 choose 4. Okay. Oh, because we have to choose 4 teachers out of 12. Okay. And since both of these are independent, so total number of ways committees can be chosen because they are independent, we'll multiply. So total number of ways committees can be chosen will be multiplied. Okay. Will be chosen. Will be 12 choose 3 times 12 choose 4 because they are independent, so we'll multiply. So this 12 choose 3 using this formula is 220. Okay. And 12 choose 4 is 495. So if you multiply both 220 times 495. So this will give 108900. Okay, we'll use this formula. So this will be like factorial 12 over factorial 9 over factorial 3. Okay. So there are 108900 ways when where total number of ways committee can be chosen. And they are independent, both are independent, so we multiply. So these are the total number of ways the committee with 3 teachers in maths and 4 teachers in physics can be chosen. Now, what we'll do is now we'll find the total number of ways when John is in maths and physics, both the committees. So, total number of ways. Okay. So, total number of ways when John is in math and physics committees in both the committees, that will be because he is already being because he is in both the committees. So now there are 11 members left, and we have to choose two because in maths, because John is already there. Okay. So out of 12, now 11 places are left. There are 12 teachers. S- So one John has already been selected. So now from the 11 teachers, we have to select two teachers for maths. And similarly for physics, because John is already there in in a physics committee. So now 11 teachers are left, and we have to choose three. Okay. So again, using this formula, nk, and choose k is factorial n divided by factorial n minus k divided by factorial k. We calculate this. So we get 11 choose 2, we get 55. And 11 choose 3, we get 165. Okay. So it is 9075. So this is the total number of ways where John is in math and physics, both committees. So total number of ways where the committee can be chosen was 108900. These were total number of ways, total number of ways committees could be chosen with no restriction. Okay. And this is total number of ways when John is in both the committees. Okay. So number of ways John is in both committees, because he doesn't want to be in both the committees. So when we subtract these, we will get when the ways when he is either in one committee, either in maths, either in physics, or in or neither, or he's not in any committee. So this will give us 99825. Okay. So what we did first, we found out the total number of ways committee can be chosen. So that was 12 choose 3 for this was for maths, and 12 choose 4. This was for physics, and we multiplied this and we got this. So these are the total number of ways where committee can be chosen without any restriction. Now, John doesn't want to be in both of both. He wants to be in neither, or he wants to be either in physics or in maths. So we can find out either, we have to find three things: when he could be in maths, when he could be in physics, or when he could be in neither. Instead, we found out when he is in both. So when we subtract, so how do we find when he is in both? We do one, when he is in both means he is in maths. So now 11 members are left and we have to choose only two because one John is already chosen. So 11 choose two gives us when the choice when John is already in math committee and we have to choose other two members from remaining 11. Same with the physics. When he is already in physics committee, we have to 11 members are left, 11 teachers are left, and we have to choose three from that. So that we can get 11 choose three will give us the number of ways we can select three teachers out of 11 remaining for physics committee when John is already on the physics. And now since both are independent, we'll multiply this. 11 choose T 2 multiplied to 11 choose 3. This will give the total number of ways when John is in maths and physics committee both. So when we subtract uh, the ways when John is in both the committees from the total number of ways committee can be chosen, we can get a number that gives us the value when John is either in physics or either in maths committee or is not in any committee. Okay, thank you. Please let me know if you have any doubt. Thanks.